Hello and welcome. My name is Lubna Sanadi and today we will be discussing about quantum cryptography. A quick review of what we will be covering today is cryptography, quantum computers, quantum cryptography, applications on quantum cryptography, and its advantages and disadvantages of quantum cryptography. So let's start with cryptography. What is cryptography? Cryptography is a security technique that hides the real meaning of something so only specific people can understand it. In the modern world, when we talk about cryptography, we talk about changing the look of the readable data by encrypting it using a set of algorithms where it becomes a ciphertext. In the modern era, everything is handled in numbers. Therefore, these algorithms are math-based. A key is an important part of an algorithm. It is used to encrypt and decrypt the data that is shared and owned by these two parties in order to understand what is received. So why do we use cryptography? It is the first countermeasure against those who try to obtain targeted data. But does it fully protect? No, it doesn't, since the strength of encryption and the size of the keys are limited by the algorithm used or, in most cases, the machines that decrypt it. Therefore, it has a chance of being broken. So what do we need to avoid it being broken? We need a stronger encryption. However, that leads to a harder decrypting process. This could be limited by a machine's capability of doing extremely large computing, where some algorithms could take thousands of years to be mathematically broken using supercomputers. This could be solved by using quantum computers. But what is a quantum? A quantum is the study where particles like electrons can exist in discrete states, meaning that electrons can only have certain well-defined values of energy when it transitions between these values by absorbing or emitting specific amount of energy. When we talk about quantum, we usually refer to photons in technology. A photon is the basic unit of light. For an example, it is what it travels in a fiber optic cable, where it represents the data in a pulse form. A pulse form is similar to electrons traveling through a normal cable, which is also known as a copper cable for an example. When it lights, it indicates a 1, and when it doesn't transmit a photon, it means 0. But photons in quantum computing, we call them quantum bits or qubits. Now, a qubit can hold more than one value of zeros and ones at the same time. This is called superposition, making it different and more complicated than bits. So, what is quantum computers? It is the next step in development of computer machines, where it surpasses even supercomputers in speed and strength. Unlike all the previous machines that use electronic bits to represent the data, a quantum computer uses qubits to transmit, receive, and store the data. This allows the ability to compute faster than a supercomputer, like factoring large numbers using complex algorithms. However, with all its advantages, it will not be able to replace the current machines because of its complex build and use. This type of machines aren't in the most perfect capability, since the field is still under heavy studying by various scientists. On the right here we can see how a quantum computer looks at the current moment. So now we have all the basic understanding. Now we can talk about quantum cryptography. So what is quantum cryptography? Quantum cryptography, also known as quantum encryption, which is a method used in encrypting to transmit data safely. It depends heavily on the laws of quantum physics, and it shows a potential in being way more secure than the previous types of cryptographed algorithms, and in theory unhackable because of the nature of the qubits. It appeared with the rise of quantum computing. Since quantum computers can break algorithms faster than supercomputer, therefore this poses a threat. So quantum cryptography appeared to counter their strength and threats. It is not being widely used today because of the limit of the current technology and studies regarding this field. So, What are the current applications and uses on it? QKD, or quantum key distribution, is the most studied application on quantum cryptography. QKD, as its name, quantum key distribution, only encrypts the key shared between two parties by using a series of photons to transmit a random key. Another application on it is mistrustful quantum cryptography, which is used to ensure both parties share good intentions. An example on it is to secure computations. Quantum coin flipping is also used between two parties that don't trust each other, where they communicate through a quantum channel. Coin flipping aims to reduce the chances of cheating. Bounded and noisy quantum storage model. This is also a very interesting application, where a constant Q limits the qubit storage, making parties exchange more than one qubit. And since storage is limited, large data must get measured or discarded. This forces unwanted parties or not so trusted parties to apply this approach, which makes the protocol to find a way to overcome the end results once it finds the unwanted party. Measurement Device Independent Quantum Cryptography, or in shortcut MDI. It protects against malicious devices by removing all attacks from the detection system. This makes its own security, not depending on the quality and integrity of the physical device's uses. So, this leads us to advantages and disadvantages of quantum cryptography. So what makes quantum cryptography so unique? Simply that it relies on the laws of physics. The nature of a qubit gets altered when read. Therefore, if someone intercepts the process of transmitting, it gets cancelled, like in the case of a quantum key distribution. A new key gets transmitted after cancellation. Remember, this only happens when someone tries to intercept the process of transmission. It also has a true randomness because of the unpredictable state of a qubit. And let us not forget the speed, where it's way faster than a normal electronic bit. However, everything has a downside. With its big security comes the cost of adaptation, since it can only be transmitted using a fiber optic cable and received by quantum devices. Another downside is its limited range, because a photon cannot hold the same shape for a long distance. It might be unhackable, but it might be prone to side channel attacks. This attack aims to intercept the information in its transmission process, and since a qubit needs sensitive sensors, this seems like a possible threat. And like this, we reach the end of the video. Quantum cryptography is a very wide field, and it's a new field, meaning that it's under constant change. Thank you for listening.